Hello, and today we're gonna see how a t-test works. The t-test will be using statistics and mostly on research to eliminate the bias between the two different trials or two different amount of information, because normally on science we want reliable data to describe and say what we're trying to communicate to the public, but we need to do that between the differences that we have between the two trials that we're looking at. We're going to see an example. Basically, a t-test is a static that checks if two means or averages are reliable or different from each other. This means that even though we have the mean, we have that as descriptive statistics, the t-test would allow us to do inferential statistics. What does that mean? That means that the t-test will allow us to make inferences about the population beyond our data. This is why this is normally used in research. A t-value is basically the variance between two groups over the variance within those groups. A small t-value will refer to similar groups, and a big t-value will be different groups. If we are working this on Excel, normally we set the difference to be 0 or another set difference depending on the hypothesis that we have. Normally, we have a hypothesis that, for example, two different people are going to score a certain test after studying really good. So we will set the difference to 0. However, if we had a two-pair data in which we were looking at only boys and girls and their height, for example, then the difference won't be 0, or we are not going to expect it to be 0 if that's our hypothesis. If the hypothesis is that we don't expect a difference, then that's going to be the value that we're going to use for that on Excel. But we're going to use also another formula to know how to do it by hand. And we are going to also look how do we know that the t-value is big enough to show the difference. The t-value, we know that it's going to have a p-value that is going to be corresponding on the data sheet. The p-value is the one that is going to tell us the chance that they are actually equal. Specifically, the p-value is the probability that the pattern of data of the sample could be produced by a random data. So basically, this is going to tell us if there is a real difference or if it's fluke. So for example, if our normally the p-value that it's going to be acceptable is going to be a 5%. That means that if we have more than that, that's not going to be reliable for us. It has to be 5% or below. So we also know that big samples help, but they diminish the results. So normally we're going to take 20 to 30 people for our trials. We are also going to have that we have to decide either if this is going to be a one or two-tail test. A one-tail test, the way that it's easier for you to understand is that when we have open-ended questions, for example, if we are looking the height of a boy compared to that of a girl, then we are going to be focused on the boys, right? So we can include that as a one t-test. Then, if we are looking at the height between two boys and girls in a classroom, then we're going to have a set of data, say 10 data points for the height of these people. And then for that one, we are going to say that this is open-ended enough so that we can have a two-tail test. This is going to help you when you're computing this on Excel. A paired or unpaired. Well, how do we know that if we have a paired or unpaired data now? Well, if the data are linked, then that means that we are going to have a paired t-test. If the data are not linked, then we're going to have an unpaired data. For example, we are going to have the data here. For example, if we have the height of John at age 5 and age 15, and then we have the same thing for Maria, Amanda, Jose, and Carlos, we're going to have 5 data points of their age at 5 and the age at 15, right? So when you have a before and after situation, that means that we're going to have a paired data. An unpaired data will be if we're going to have the height of boys versus girls. There's no way that we are going to be able to go ahead and link those two numbers. We're going to have mean and values that we are going to be linked between them, but it's not linked as a before and after. If John is here and Maria is here, the height of this person is not going to affect the height of this other person, right? John here, Maria here. John is going to have 15 inches change from age 5 to age 15, and then Maria may have 10 inches of difference, which means that whatever he did during those 10 years is not going to affect her at all. Now, for the value when we are trying to compute this manually, we're going to have that the degrees of freedom are going to be basically n minus 1. And what is n? N is the total amount of samples or trials that we have on the t-test. And the t is going to be calculated as the change, well, not the change, but the mean value of all the differences divided by the square root of the number of samples times the summation of all the d's squares minus the summation of the d's squared over n minus 1. N minus 1 is our degrees of freedom. For example, if we have 25 students or 25 trials, that means that our degree of freedom is going to be 24. We also have proposed level of difference, which is alpha, which, as we saw before, it's going to be 0.05 most of the time. Here you can see how I've written it down so it's easier to understand, and we're going to see also the degrees of freedom. So as we saw before, 25 students minus 1 is going to be 24. That's going to be an example of degree of freedom, which is equal to the sample size minus 1. We know that the types of t-tests are also going to be independent samples, paired samples, or one sample. Independent samples are common to groups between samples on paired t-test. Paired samples are that the test, we are going to test the mean of two groups. Or say we're going to test the difference twice. And then one sample, we're going to test the mean of one group compared against a set of hypothetical mean. That means that we're going to compare the mean of one exact group with the mean of a bunch of people, and it's a set or hypothetical mean. We know that the ideal p is going to be less than 5%. That's p less than 0.05 when you're doing it on Excel. We know that there are some other limitations to this type of test. One includes that we are going to have that the results of the differential statistics can only be applied to the populations that resemble the sample that was tested. Also, your sample and your population should be roughly normal in distribution. This means that the score will be around the mean, with fewer scores further and resembling a bell curve. Each group should move about the same number of data points. Combining large and small groups together and may give inaccurate results. All data points should be independent. This means that the scores should not be influenced by each other, as we saw with the boys and girls. Data approximates in interval levels or higher. This means that each unit measurement should be about equal to the other unit. Thank you so much.